Let's now move here for the ideal op-amp characteristics. Ideal characteristics. What happens in ideal characteristics? Input resistance needs to be infinity. Okay. Output resistance needs to be 0 ohms. Okay. What about gain? Infinity. Awesome. Okay. So the graph that you had over here, this one right here, that was for the op-amp, realistic characteristics. What would happen in an ideal op-amp situation? Well, if the gain is infinity, that would mean that VP minus VN needs to be 0. So at 0, you will have the infinity, gain as infinity. Okay, again, I can put that equation again. V naught was equals to A times dot Vn, correct? So Vn was equals to V naught over A. If A is going to be infinity, and if I put V naught over infinity, that is equals to 0. So Vn equals to 0. So if Vn, this on the x-axis, this Vp minus Vn is 0, that means gain is going to be infinity. That's the linear region. We want our operation amplifier to work in this region, okay? And by now you should know what's happening over here, that because we have reached the positive rail value, so it will just flatten out over here. So it's going into saturation. So this is the positive saturation region. This is the negative saturation region. So ideally, this is how it is supposed to work. Now, what is next here? And these are just all, very, very basic. And then, knowing all this stuff is really going to help you understand, doing AC analysis on some of these circuits on Thursday. Once you get this, then everything will be just, straightened out, and then things will work. Okay, a few more things here. I already talked about the input resistance infinity, output resistance V naught, gain infinity. That would mean Vn equals to 0 right here. What else? Am I missing anything? I talked about the current, right? I positive and I negative. Those are going to be 0 amps, right? And Opamp has the an output operations over here. Good. Good. So we got all the basics covered. Let's move on to the next page. So what are the golden rules? So based on what we just learned, let's just formally state the 2 golden rules of op-amps. And what are they? Okay, so number 1 is the output attempts to do whatever is necessary to make the voltage difference between the inputs 0. Okay, so what basically that statement is saying, maybe I can go here. Yeah, this output right here will do anything with the help of this beta factor over here to get the voltage over here at the negative terminal equal to that of the positive terminal, because only when Vp and Vn are same, that is when we get Vn equals to 0, correct? Vn equals to Vp minus Vn. So they two need to be equal so that Vn equals to 0. So one thing for sure we learned here is that the output attempts to do whatever is necessary. The output attempts to do whatever is necessary to make the voltage difference between the inputs 0. Okay, cool. What is the second thing? Second thing, no input, right? No input current flowing into the op-amp. And basically remembering these and applying these golden rules, we should be able to simplify or analyze some of the circuits. So with these 2 rules, we are now ready to solve any ideal op-amp circuit.